Hello class, welcome back to the Chong channel. Right now this is a continuation of the review for the algebra final for question number 2. Okay, so let's start reading the problem. Here it says, on the day Alexander was born, his father invested $4,000 into an account. So let's annotate. Invested $4,000 into an account with a 1.4 annual growth rate. Write the function a is a function of t that represents the value of this investment t years after Alexander's birth. Okay, so that's the first part of the question, so let's title this A. And this is the second part of the question, determine to the nearest dollar. Just a quick review, when you're saying to the nearest dollar or to the nearest foot, any word that does not have a THS at the end, like tenths, hundredths, thousandths, if it does not have that THS at the end, it means whole number. So we have to round this to the nearest whole number. Okay. Next part, it says, how much more will the investment be worth? So how much more will the investment be worth when Alexander turns 35 than when he turns 18? All right, so this is an exponential function. So let me just take some notes here on the side. So exponential function is when something grows at a fast rate or when something decreases at a fast rate, okay? So here we know that this is a growth. Now before that, let's just go over a general formula. Now, if you were to Google this, like exponential functions or look it up, there's a specific standard formula, but I tend to change things a bit. So if I wanted to find the value of anything, it's always going to be the original amount times 100% plus or minus. It depends on the problem. So in this problem, we're going to do plus because we're talking about growth. And if the problem were to talk about decay or decrease, that would be minus. So you would do 100% plus whatever percent they gave us, or 100% minus whatever percent they gave us. And this number has to be in decimal format. And the exponent would be time. Now, my formula is a little bit more different, but that's okay. So here we have the function a is a function of t. Now, the original amount that the father invested was $4,000. So I'm going to put 4,000 as my original. Now here, this was an annual growth rate, so we know we're going to add. So we always compare it with 100% because 100% means the original, okay? So 100% plus, and the percent they gave us was 1.4%. Okay, so now let's do some math here. So I'll change the color so you know I'm doing some work here. So 100% plus 1.4% is 101.4%. Now, if you remember, whenever you want to change a percent to a decimal, you move 2 places to the left, or you can put that number over 100. So once again, if I wanted to change a decimal to a if I wanted to change a percent to a decimal, I move 2 places to the left. And if I were to do that, that's 1, 2, and so that's 1.014. Okay, this looks kind of messy, but don't worry, bear with me. All I did right now was did 100% plus 1.4%, and I changed it to a decimal because this number always has to be in decimal format. And then the time, well, the time here is a general t years. So let's rewrite this right here. A is a function of t, so this is the value of the investment. So let's write value of investment equals original, which was 4,000. It's not necessary to put it in parentheses, but I'm just going to do that just so I have my consistency here. And then the 100% plus 1.4% changed to a decimal was 1.014. And then the exponent was time. So this is the first part of the question. We wanted to write the function. Now, the second part of the question is asking about how much more money would it be when this guy turns 35 than when he turns 18. So there's multiple ways to do this. You can plug this into the calculator, but let's pretend we don't have that calculator and I'm just going to substitute values. So first, I'm going to plug in the 35 where I see time, because that's the number of years after the birth. He turned 35 equals 4,000 times 1.014, and the exponent here is 35. So when I plug this in the calculator, literally I'm copying the same thing I see on the screen. It's 4,000 times 1.014 exponent 35, and I get as follows. It's an ugly decimal, but remember, I like to copy extra digits, so it's always I copy the whole thing in the front and then 4 numbers after the decimal. It's just something I like to keep consistent. Next part, I'm going to plug in 18. So once again, T years after Alexander's birth, he was 18. And then it's 4,000. 1.014, and then where I see the time, I'm putting 18 this time. Like I said, in the calculator, you're putting 4,000 times 1.014 exponent 18, and we get 5,037.3976. Now, I never round early. You always round at the end. So we're actually not done with the problem yet. So right now it says how much more. Well, it's obvious this one is more, but we want to know how much more. So what we're going to do is subtract. So 6507.1140 minus 5137.3976. And I'm going to plug this in the calculator exactly as I see it. And when we do that, we get 1,369.7164. Now, remember, we're talking about money here. So money involves dollars and cents. But however, in this question, it says round to the nearest dollar. So we're really focusing on the nearest whole number. So we underline the last digit of the whole number. Look at the next number. If that next number is 5 or more, then that means this rounds up. So the next number is 10. So I put the 1. I put the 0. I carry the 1, so this becomes 7. And so this means when he's 35, he will have $1,370 more than when he would be at 18. I hope that helps.